One unique experience as a math teacher is the realization that students make or are prone to some certain errors in their understanding of mathematics. And this kind of errors in algebra, geometry, they get in their way of mathematical progression. You know quite well sometimes that when they write the exams or tests, they know what they are working towards to, but these errors will affect their final outputs, which themselves are not happy about. In the light of this, I'll be looking at common mistakes students make in mathematics. Now, let's look at common mistake number one. This is an algebra. Is to the student assume that a plus b raised to power 2 equals to a square plus b square. I see this all the time. They make this mistake all the time. That this is clearly incorrect. Now, I would like to show you that this mistake is not correct. So, I'll make an assumption that a equals to 3 and b equals to 2. So, if I do that and plug it into the expression a plus b squared, I'll have 3 plus 2 raised to power 2, which should give me 5 raised to power 2. And 5 raised to power 2 is 5 multiplied by 5 to give me 25. Now let's now take the same substitution in the expression students assume to be correct, which is a square plus b square. So using the same substitution, a equals 3, b equals to 2. So we have 3 raised to power 2 plus 2 raised to power 2. That gives us 3 times 3 plus 2 times 2, which should give us 9 plus 4, and that gives 18. Now, obviously, a plus b square and a square plus b square, they give different answer. 25 is definitely not equals to 13. So clearly, a plus b to the power of 2 is not and in any way equals to a square plus b square. Now, it will be interesting to know what the expression a plus b to the power of 2 is actually equal to, so that and we test that also to see whether it is valid. So let's make a correction to that mistake. So a plus b to the power of 2 is clearly means a plus b twice, which is a plus b and a plus b. And to expand this, you take the second one and distribute the first one over it. So you have a bracket a plus b plus b bracket a plus b. So you expand the whole expression, that is a square plus ab plus ab plus b square, which in turn gives a square plus 2ab plus b square. Now we need to check whether this expression is equal to 25, because that is one way we can check whether it is truly the value of a plus b raised to power 2. So we check a square plus 2ab plus b square using the same substitution. A equals to 3 and b equals to 2. So we have 3 square plus 2 multiplied by 3 and multiplied by 2 plus 2 to the power of 2. So that gives 3 times 3, which is 3 square, plus, let's write again, 2 times 3 multiplied by 2 plus 2 multiplied by 2. Now this gives us 3 times 3 is 9 plus 12 and plus 4 to give us 25. Wow, interesting. So clearly a plus b squared gives us 25 and a squared plus 2ab plus b squared also gives us 25. So we can conclude that since a plus b squared, a plus b is about to give us 25 and a squared plus 2ab plus b squared also equals 25, therefore a plus b to the power of 2 equals to a squared plus 2ab plus b squared. But clearly not equals to a squared plus b squared. So I hope students will make these fundamental mistakes again. Now, understanding this, let's go to mistake number 2. Now, this is that the square root of a squared plus b squared equals to square root of a squared plus square root of b squared, which is equals to a plus b. Students are fond of making this expression. They will assume the square root can deal independently with a squared and b squared. Another variant of this mistake is that the square root of a plus b will just deal with a plus b and will get root a plus root b. So this is like assuming that the square root can like be partitioned in the middle and deal with its terms independently. Clearly, this is not the way mathematics see this here. So it is clearly incorrect. Now, but before we say it's incorrect, let's also, like in the previous mistake, let's substitute. Let's see if it's true, correct, or incorrect. So I'll use a equals to 3 and b equals to 4. So for a root a square plus b square, I'll have root 3 square plus 4 square. It gives square root of 9 plus 16. And that would be square root of 25, which will give me 5. In the same vein, let's now see whether the other expression students assume is the equivalent of root of a square plus b square. So using the same substitution, a equals to 3 and b equals to 4, this should be square root of 3 square plus square root of 4 square. And that would be square root of 9 plus square root of 16. That gives us 3 plus 4, which gives 7. Definitely, 5 and 7 are two different results. So in a way, this expression overestimates the actual expression. So clearly 5 is equal to 7. So there is no way root a squared plus b squared is root a squared plus root b squared. So this is one mistake students need to watch out for. So let's look at mistake number 3, which is one of the mistakes students make. Now this has to in the area of algebra. This is in the area of algebraic fractions. Students assume that 1 over a plus b equals 1 over a plus 1 over b. Another variant is that 1 over a plus 1 over b, they take it to be equals to 1 over ab. These are not mathematical. I mean, it doesn't exist in the mathematical dictionary if there's anything like that. So clearly, this is not acceptable in mathematics and clearly incorrect. But before we say it's incorrect, let's also try to see whether it makes sense or not. So let's make a substitution of a equals to 2 and b equals to 5. So we have 1 over 2 plus 1 over 5. That gives 1 over 0.5 plus 0.2, which gives us 0.7 for the expression 1 over a plus 1 over b. Now, we need to now check whether the other expressions will give us 0.7. So let's check 1 over a plus b. So using the same substitution, a equals to 2 and b equals 5. 1 over a plus b will be 1 over 2 plus 5, which will be 1 over 7, and that gives 0.14. Wrong. Definitely, it is nowhere close to 0.7. So clearly, it will estimate the actual expression. Now let's take the third expression of 1 over ab. Using the same substitution, that will be 1 over 2 times 5, which is 1 over 10, and that gives 0.1. 0.14 and 0.1 are different from 0.7. So we see that this is incorrect. Let's look at the correction. Since 0.7 is not equals to 0.1 or 4 and not equals to 0.1, definitely 1 over a plus 1 over b is not equals to 1 over a plus b and is not equals to 1 over ab. But clearly, 1 over a plus 1 over b is a plus b over a. This is the correct expression. But let's test that. Using the same substitution, a equals to 2 and b equals to 5, that will be 2 plus 5 over 2 times 5, which is 7 over 10, 0.7. Wow, interesting. 0.7 was the initial value we got for the expression, so this is very correct. Now let's try some exercise to test our understanding. Question 1. Which of the following, I have some expressions here, which of the following is correct? A, is it that a plus b square equals a square plus b square? B, is it a plus b square equals to a square plus b square minus 2ab? C, is it equals to a square plus b square plus 2ab? And D, is it equals to a square plus b square plus ab? This is the first mistake we look at. So I hope you not make the same mistake again. You're not going to make the same mistake again. What's your guess? Clearly, the answer is C. Alright, you got that correctly. Now let's go to question 2. Now if A equals to 5 and B equals to 12, what is the value of square root of A plus square root of B? A, is it root 5 plus root 12? Is it root 17? Is it root 60? Or is it root 7? If you have chosen B, you have assumed that it is equal to root A plus B. C is assuming that it is equal to root A times B. And D is assuming that it is equal to root B minus A. But from what we have looked at, is not in any way close to BC. So the answer is A. You cannot condense the expression like that. And lastly, the final question in this exercise, evaluate 1 over A plus 1 over B. Is it 1 over A plus B, 1 over AB, AB over A plus B, or is it A plus B over AB? Clearly, as we have looked at earlier, it is not 1 over A plus B. It is also not 1 over AB. Now, definitely it's between C and D. So, The answer is definitely B. Now, many thanks for watching the video. If you want more of this video, click on the subscribe button, and hope you have a wonderful experience. See you in the next video. Bye for now.